All right, so if we want to figure out what the limit as h goes to 0 is of this whole expression, this actually can look more complicated than it is, but what you need to realize is this is just the expression for a derivative. This is probably what you learned at the start of your second chapter in calculus, where you're doing the derivatives the very long way with like the delta x and all that. But this is just the derivative of the sine of x. So we basically find the derivative of the sine of x for a specific value of, so we're basically finding the derivative of the sine of pi over 3. And that'll just be the cosine of pi over 3. And so the cosine of pi over 3 is just 1/2, and that's it. The answer. Right, 26, we have an object that moves along a straight line so that any time t is more than or equal to 0, its velocity is given by v of t equals 2 times the cosine of 3t. What's the distance traveled by the object from t equals 0 to the first time that stops? Okay, so let's first figure out the time that it first stops. So it's going to stop, when the velocity is 0, because that velocity tells you its motion, its movement. So we want to find where is v of t equal to 0. So we set 2 times the cosine of 3t equal to 0. So this is the same as 0 equal to the cosine of 3t. So using our trig knowledge, we know that the cosine is 0 at pi over 2, 3 pi over 2, and so forth. So we're going to set then pi over 2 equal to 3t and solve for t, and that would just be pi over 6. We only need to find one of them because we want to find the first one. The first time it becomes 0. First time it stops. Okay, so now we know where it first stops. Then now this is going to tell us where to integrate until. So to find the distance of an object that's traveled from its velocity, as long as the velocity is positive, you can find it by just integrating the velocity function, in this case from 0 to pi over 6. We're just going to integrate the function to cosine of 3t from 0 to pi over 6. Take the antiderivative, we get 2 times, divide that by 3, so 2/3 times the sine of 3t. From 0 to pi over 6. So we'll just give the 2/3 out for now. 2/3 times the sine of 3 pi over 6. So the sine of 3 pi over 6, or sine of pi over 2, minus the sine of 3 times 0, or minus the sine of 0. So 2/3 times the sine of pi over 2 is 1, so 2/3 times 1 minus 0 is just 0, or is just 1. So 2/3 times 1 is just 2/3. So answer is C. Okay, 27. So we have this table that gives values for x, f of x, and f prime of x. And so we want to find what f inverse, or what the derivative of the f inverse evaluated to is. So we're told that the f inverse function is given. Well, it's not given in the table, but this represents the inverse of the function f. So what we're going to do is there's actually an equation that you can use to find the derivative at a specific value of an inverse, which is basically it's probably given to in your textbook or in this form, like the f inverse, or the derivative of the f inverse at some value, we'll say usually maybe a is equal to 1 over f prime of f inverse evaluated at a. So like that. So we're trying to find trying to find this equation for when a is 2, so we're essentially trying to figure out this. The derivative of the inverse at 2, so that'll be 1 over f prime of the f inverse of 2. So let's see what we get. So the inverse at 2, the inverse function evaluated at 2, is essentially going to be the value of f of x that results in 2. Like what value gives you 2 as the output for f of x. So here, like we look where the output is 2 for f of x, which is here, and we're gonna have we're gonna have like this expression is gonna be x is 1, or the input is gonna be 1. So it's like working backwards. If it was f of 2, you would go from here to there. You go from 2 to there, but since we're going to inverse, we go from the 2 to the 1. Anyways, now we just have to find the derivative at 1. That's right in the table. F prime of 1 is negative 8. So this is just 1 over negative 8. So our answer is just B. All right, so now we have a related rates problem. So we have the top of the 15-foot ladder that's resting along a vertical wall. The bottom of the ladder is on ground level or level ground. And it's sliding down the wall at a constant rate of 2 feet per second. So let's draw a sketch first. Since what's going on. The ladder is this. It's going down, so this we can say dy, the change in y with respect to time is equal to negative 2. We want to figure out what rate in radians per second is the acute angle between the bottom of the ladder and the ground changing at the instant that the bottom of the ladder is 9 feet from the base of the wall. So we're studying this angle here. Angle is going to be shown or given by this part of the triangle, and the 9 feet from the base of the wall means that the base of the triangle is going to be 9. So we want to basically find d theta dt. So there's a couple different ways to go about these. You want to use a trig function. So what I would use is the sine function, because I know we can see we have like the y and the hypotenuse, and they already have a couple values given to us. Anyway, so what we know is that the sine of an angle, so the sine of theta, is going to be given by the opposite side over the hypotenuse. So basically it would be y over 15. Sine of this angle is y over 15. This is our y. Now we can find the derivative, or we can get this by differentiating this, because this is a function. This is going to be a composite function. It's going to be implicitly defined. So if we took the derivative of this, we're going to use chain rule, where we take the derivative of theta, so we get d theta dt times the derivative of the outside, so times the derivative of the sine function, which is the cosine of theta. And on this side, the derivative of y over 15, it'll be just first move without 1/15 is just a coefficient, times dy dt. Again, think about using probably what you learned in chapter 2 or unit 2, the implicit differentiation. The derivative of y will just be 1, so 1 times dy dt. And then from here, we're just solving this algebraically. So d theta dt, we know that dy dt, it's given as negative 2. So we have negative 2/15 divided by the cosine of that angle. And the cosine of the angle, just from trig, is going to be the length of the adjacent side over the hypotenuse. So this will just be negative 2/15 over 9/15. And then so then that just becomes negative 2 over 9. And then our answer will be A.